We have so far built multivariate non-parametric models using kernel density estimation. We can also ask the question, are there outliers in the data? The Mahalanobis distance for a single variable x can be defined this way, where mu x is the mean value for x and S is the covariance matrix. We use the inverse of S here to get this product matrix. Similarly, for two identically distributed variables x and y, we take the difference transposed and use the inverse of the covariance matrix and then the difference and multiply them together. In both cases, the values are always positive definite since it's a true distance function. The Mahalanobis distance gives us a simple way to look for outliers in the data. The square of the Mahalanobis distance in 2 dimensions or with 2 variables is equal to the chi-square with 2 degrees of freedom. Thus, that distance directly gives us how far these values of data are from their central tendencies in the probability distributions. In our case, we had 2 distributions of F1 and F2. F1 was the average Medicare payment amount and F2 was the average Medicare allowed amount. We had inspected these 2 distributions and they seemed to be quite identically distributed. Assuming they were identically distributed, given that F1 and F2 were quite identically distributed, we had the derived variables x and x bar identically distributed. Can we look for outliers in a joint distribution of x and x bar? Moreover, if we do find outliers using the Mahalanobis distance, we can still ask the question, what do these outliers mean? Well, we will leave it up to you to find what the meaning of these outliers could be. Let's go back to the IPython notebook and implement the code for the Mahalanobis distance and see if we can find some outliers in our variables x and x bar.